Today's lesson is multiplying multi-digit numbers. It's lesson 3.5. One of the vocabulary words that you need to know this lesson are partial products. Partial products are products that are found by breaking apart one of two factors into ones, tens, hundreds, and so on, and then multiplying each of these by the other factor. For example, if we have the factors 462 times 16. Okay, those two numbers are factors. We are going to choose one of them to break apart. Okay, breaking apart number 16, that's going to be 110 and a 6. You're going to keep the other factor the same. So 462 and 462. You then created two equations, equation 1 and equation 2, out of this original equation. Okay. When you have multiplied the two new equations, that's going to give you two partial products. Then when you add them together, they give you the final product. Sometimes it's easier for you to break apart or use partial products because it's easier for you guys to multiply by a one-digit number or a number that is a multiple of 10. Let's look at an example. It says, how much does the Carson family pay each year for their cell phones? You could use a bar diagram, can be used to show joining equal groups. You could also use the commutative, associative, and distributive properties to make the computations easier. Okay, you know that a cell phone bill is $271 per month, and they want to know for the whole year. Looking at this diagram, it shows N at the top, which is the total for the year. It also shows 12 boxes with the number 271. Those 12 boxes represent the 12 months in each year. 271 represents each month's payment. To multiply them together, you will get N. Step 2 shows you how to use the traditional method to solve this problem. The two partial products in this equation are 542 and 2,710. When you add them together, you get your answer of 3,252. They ask if that is a reasonable answer. I would say yes, because 271 is close to 300, and 12 is close to 10. You learned in a previous lesson that 300 times 10 would be 3,000. 3,000 is close to 3,252. I would suggest it's reasonable. Let's continue on with examples. Carlos saves 18 cents every day of the year. If there are 365 days this year, how many cents will he have saved by the end of the year? Write an equation that represents the problem. Then solve it. Okay, so an equation. That means that we need to have a equal sign, okay? And we need to have an operation. Since we've been using multiplication, I would think multiplication would be a good operation. There are two numbers used in this problem, in the story problem. I would say we should plug them in. 18 cents every day multiplied by the 365 days we have in a year. That looks like a pretty good equation to me. Let's use partial products to solve it. Let's take 365 times the 110 that we have times 10. Hold my 0, 5, 6, 3, 3,650. And then let's take 365 times our ones place, which is the 8, and we'll get 40. 48 plus 4 is 52. 5 times 3 is 24, plus 5 is 29. We're going to add those two together and get 0, 7, 15, and 6. So our answer would be 6,570 cents. Let's look at another one. This one actually shows boxes for you to use. You may use them if you find it easier. If you do not, don't worry about it. I'm going to use the boxes. 6 times 8 is 48, so I have my 8, carry my 4. 6 times 0 is 0, plus 4 is 4. 6 times 2 is 12. I'm done with my ones place, so I'm going to move on to my tens. I have to hold my place with a 0. 2 times 8 is 16. 6, carry my 1. 2 times 0 is 0, plus 1. 2 times 2 is 4. Noticed I did use two different colors. That's just to help you guys visualize which one was for the ones place and which one's for the tens place. And then I'm going to add the two together. And I'm going to get 8, 10, carry my 1, 4, and 5. So my answer would be 5,408. If you use the boxes, they do help and give you some assistance on knowing how many numbers there should be. They always give you the right amount of boxes. One more for your I-step practice. It says Jack estimates the product 257 times 29 is less than 6,000. Marta disagrees. She estimates the product is more than 7,000. Whose estimate is better? Explain your thinking. Let's talk through this together. 257 times 29. From lesson 3.2, we learned how to estimate, and 257 is pretty close to round up to 300. 29 could round up to 30. Multiplying 300 times 30, 3 times 3 is 9, and we have 1, 2, 3 zeros, and I got 9,000. Granted, we did round up. When we went from 257, we went up to 300, and from 29, we went up to 30. So we do have an overestimate, but 9,000 is quite a bit off from 6,000. Let's try, instead of rounding 257 to 300, let's round it to 25 or 250. And we'll keep 29 at 30. This time I'm just going to multiply 25 times 3, which is 75, and then add my two zeros. I still get 7,500 if I underestimate. That leads me to believe that the product or the answer to our problem is going to be more than the 7,000. Our assignment for today is page 141 and 142. Please complete numbers 4 through 10, just the even ones, meaning numbers 4, 6, 8, and 10, and then 14 and 18. Today you do not have to do the C17 for IXL. We will complete that at another day. Thank you, and please work hard.